Hi, I'm James Eastham, a developer advocate here at Datadog, and in this video you're going to learn all about the importance of following some form of standardization when you start adding observability to your asynchronous systems. Picture the scene. You've just implemented distributed tracing in your event-driven system, and you've watched this series of videos so you've got your own view on how tracing should work in an asynchronous system. But maybe other teams in your organization have also implemented distributed tracing, but slightly different way. Slightly different naming conventions, slightly different ways of structuring spans, and whilst you're definitely further forward than having no telemetry, you start to wish for a little bit more consistency in the world. And that's where the semantic conventions come into play. Semantic conventions, or otherwise known as best practices, help ensure consistency across all your systems. They make it easier to analyze and correlate data. Semantic conventions are managed by the Open Telemetry Project, and they're simply just standardized attributes for your observability data. If you imagine you're building a synchronous HTTP API, things like the HTTP status code, the HTTP request path, and the HTTP method that a call used are standard attributes that really are useful to understand for all APIs in your system, because then you can start to look at how many HTTP 500 status calls have there been in the last hour, for example. Now, messaging systems also have their own set of semantic conventions, and these make it easier to analyze and correlate data to show you consistency across all of your systems, which starts with a description of what you should actually call your spans. Here you've got publish spans, you've got subscribe spans, you've got process spans, you've got acknowledge spans. You should create a span for the processing or publishing of an individual message, and then that's publish or process, and then the actual name of the message that you're processing. So if you're processing an order created event, the name of that would be process or created. Simple, right? You've then got some other things in here around the actual attributes that your spans should have. I'll put a link to this page in the description below. Again, you've got the operation name. Is this a processing span? Is this a publishing span? You've got the messaging system that you're using. Are you using Kafka? Or are you using SQS? Or are you using SNS? The number of messages in the batch, the type of error. There's a whole bunch of really useful things in here. Things like the message size, the client ID, who is consuming this message, the ID of the actual message, the unique identifier. And there's some important ones that aren't in the semantic conventions, things like the message type. Is this an order confirmed event, an order created event, a product created event, and also the version of the message. Now, in practice, this is relatively straightforward. Inside your actual application code, whenever you process or publish a message, all you need to do is simply create a new span. There's an example here in Node.js. Whatever programming language you're using, there's an example for that in the GitHub repo that's linked in the description below. So here you're starting a new process span, and you'll notice that the name of the span is process and then the type of the event. So here, this span will be process, order, created. And then underneath here, you're adding a whole bunch of different attributes. The type of message, the messaging system, the size of the message, and also the size of the envelope. The name of the client consuming the message is set to be the name of the function. And equally, when you're publishing spans, the exact same things applies. You create a new span called publish, the name of the event that you're publishing, and then you've got the type, the domain, the number of messages in the batch, the destination. Is this an SQS queue, an SNS topic, a Kafka topic? And again, the size of the message, the size of the envelope. And this is really easy to do, whether you're using Open Telemetry, whether you're using a native tracer. You just create a new span, add a bunch of attributes, and you can create some kind of utility method in your application call, which means you can just call start publish span with semantic conventions, and you can centralize all of this logic in one place. Now, you might be wondering, what is the actual benefit of doing this? Particularly when you're building an event-driven system, this starts to get really useful, because one of the most difficult things to understand in an event-driven system is cause and effect. Is who is upstream of you, whose messages are you consuming, but also who's downstream of you, who's consuming the messages that you are publishing. So what this actually allows you to do is actually start to ask some really interesting questions of your system. Imagine you're a developer on the product service and you need to make a breaking change to the product created event. And to do that, you first want to go and talk to all of the teams that are using the product created event. Now, of course, you could just send out a Slack message. You could hope that people respond to you asking politely if they're using the product created event. Or if you've instrumented your app with the semantic conventions for messaging, you can simply come to your observability backend. You can run a query for show me all of the spans with a name of process, product.productcreated.v1. That's the name of the message that I'm publishing. And if I run that query, I can see that there's a whole bunch of spans here that are process product.product.created.v1. I can then start to aggregate my trace data here and actually group this to show me all of the spans grouped by service. And I can see that in the last 15 minutes, the inventory service has consumed 121 product created events, and the pricing service has consumed 90. I've just used my actual observability data here to understand who are the downstream consumers of the event that I publish. I now know that I need to go and have a conversation with both the inventory team and the pricing team to actually check that the change I'm going to make to the product created event is okay. And equally, if you're a developer of the inventory service and maybe you want to see, I don't actually know who publishes the product created event, if I change that query to publish product.product.created.v1, I can now see that it's the product service, clearly, that is publishing the product created event. So once you have this standardized set of attributes on all of your spans, you can then start to aggregate that telemetry and run some really interesting analysis. Here I've put together a really simple dashboard that is just aggregating trace data to give me an overall look at the system and how it's functioning. So I can see in the last hour, there have been 3,000 messages published with an average size of 355 bytes. The average message age on processing is 703 milliseconds, and there's been 342 messages processed. I can then start to filter this dashboard. Maybe I'm a developer on the inventory service. I can filter this down to the inventory domain. And actually I can see that in the last hour, I've published 1,800 messages with an average size of 477 bytes. This is all aggregated from trace data. Because you've got that standardized set of attributes on all of your spans related to messaging, you can actually start to draw some insights from your system at a really high level. So although distributed tracing is kind of a prerequisite for building asynchronous systems, adding these semantic conventions to all of your telemetry across all of your systems that do anything related to messaging take that telemetry to the next level, because it allows you to start to draw really interesting insight across all the services across your entire system. Instead of relying on out-of-date documentation or talking to each other or relying on this kind of tribal knowledge of how a system works, your telemetry becomes a form of living documentation. You can go and run queries in your observability backend to look at, show me all of the spans that are processing a order created event. Aggregating that in certain ways allows you to visualize exactly what is happening across your entire system to the order created events. So whilst custom business context and custom information is really useful, having this standardized set of spans and attributes across all of your systems allows you to draw this high level insight. And now, instead of relying on having metrics being published as well as your traces and all these different things, you can aggregate your telemetry to get that macro level view from the individual requests that are flowing through you. So remember, distributed tracing is incredibly useful, but make sure you add some context. Make sure you standardize on what that structure of that tracing is going to look like. And using the semantic conventions is a fantastic way of doing that. I'll see you all in the next video.